Okay, we're going to work through solving for x in this right triangle. And this says it's question 23, but it might be question 19, depending on which worksheet you're looking at. For the class I'm making this video for, it's number 19. Okay. So then what we want to do is identify the sides of the triangle, like identify the hypotenuse first, like I've suggested before. So the longest side or the one across from the right angle. So it looks like this side here would be the hypotenuse. And then identify any other sides that are marked with either a number or a variable. So see how this side over here, even though I know that's the opposite side, I'm not actually going to write down opposite next to it because it doesn't have a number or a variable, so I'm not going to use it in this problem. So what I do care about is this one here with the x. So I identify that one is next to the angle, so that one's adjacent. Okay, so the reason I labeled just those two and not the opposite is now I want to focus in on SOHCAHTOA and think, hey, which one uses those two sides? Which one uses the adjacent side and the hypotenuse?
The column?
Yeah, so it's cosine that uses the adjacent and the hypotenuse sides for the ratio, right? So we set up our ratio by saying the cosine of 32 degrees. So what that means is anytime we have a triangle with a 32-degree angle, it doesn't matter if it's 13 or what this side is. Anytime we have a cosine with a 32-degree angle, it's going to have the same ratio. And that ratio can be given to us in decimal form by a calculator, right? So that's what this means. This is connected, like, I don't know, things that are connected. Peanut butter and honey, or, you know, this cosine is nothing without the angle. We don't know the ratio unless we have the angle that it refers to. So the 32 is the argument of the cosine function, or the cosine ratio, and we have to have them together. Okay, so that is equal to the actual ratio, which we're going to use these numbers or variables for. So cosine is represented by adjacent over hypotenuse. So our adjacent side is labeled with an x. I'm just going to write x over the 13, which is the hypotenuse. So here I have written down the cosine of the angle is equal to the adjacent side over the hypotenuse. So I'm just using that definition for cosine. That makes sense?
Yes.
Now we solve the problem. So the way I like to solve these is by using, you can either use an inverse operation where the opposite of dividing 13 is multiplying 13, or I think about it usually as cross-multiplying. So solve by cross-multiplying. It ends up the same regardless of which way you think about it. So cross-multiplying typically is done when we have two fractions. Right now we only have one fraction on one side, but I can turn this side into a fraction by putting a 1, so that my cross multiplication now makes sense, I hope. So then we cross multiply. So that means that x, 1 times x, is equal to 13 times the cosine of 32. I don't really need that dot, I just wrote it to help us remember we're multiplying. Now calculators can be put into a degree mode or what we call a radian mode. And you might have learned about radians last year in Math Secondary 3. We are not using radians at all in this class. So you want to make sure your calculator is always in degree mode. Calculator in degree mode. Okay, so then all I have to do is type this into my calculator, 13 times the cosine of 32, and it will give me an answer. So let's do that, see what we get. Excuse me. So my calculator says 11.02462525. Alright, so our instructions say, though, to just round our answer to 2 decimal places. So that means I can leave my answer as 11.02. Oops. I love it when I say one thing and write something else. And so that should be the length of this side. It's always a good idea to stop and think about if your answer makes sense. So if the hypotenuse, which is the longest side, is 13, then this shorter side being 11 makes sense to me. What wouldn't make sense is if we had gotten an answer bigger than 13. We would have known we'd done something wrong, because the hypotenuse has to be the longest. If you want to break this down into more steps, you can. So just to kind of see what that would look like, cosine of 32 has a value, right? So I just wanted to kind of refer to that. So the cosine of 32 by itself has a value which we are giving as a decimal because some of them cannot be written as fractions, even if they are ratios. So this is, and the way that we know these values, well, now they're probably computer generated, but back hundreds of years ago, there were actually people that would be, maybe monks in I don't know, that's what I've heard. Monks sitting around all day and drawing these precise triangles and calculating out the values for the ratios for each angle using triangles that are just drawn precisely. So if you can imagine how these ratios or these decimals have evolved over the years based on that result. But anyway, so the idea behind this is the calculator is providing this decimal. So you would get the same answer if you just multiplied 13 times the 0.8480, etc. You should still get that 11.02. Even if you just use 4 decimal places, I still got the same answer. I just highly recommend letting your calculator use as many decimal places as possible for the most accuracy.